When adding whole numbers, the numbers being added are referred to as addends, and the result, or the answer in the problem, is referred to as the sum. So if we're adding 5 and 3 to get 8, 5 and 3 are called addends, and 8 is called the sum. We could say then that 8 is the sum of 5 and 3. Now, addition can be illustrated using a number line. We talked earlier about the numbers on the number line referring to distance from 0. 5, for example, is a distance of 5 units from 0. Well, that 5 units and distance generally can be taken anywhere on the number line. For example, I can think about 5 units from the digit 4 to the digit 9. You see, this is 5 units, 1, 2, 3, 4, 5. You see that distance of 5. Now, in thinking about it like that, we can identify the first addend as just being the distance, you see, to that addend on the number line from 0. 5 is right here. So when we think about adding, we're going from here to this position. And then when we add, we just tack on another distance, you see, according to the other addend. And the other addend is 3. So from here, let's go a distance of 1, 2, 3, and that would put us in this position where the 8 is as expected. So we could accomplish addition in this fashion. Of course, it's a little inconvenient if the numbers get particularly large, as they will very shortly. But maybe we can imagine it this way at least. Here are some properties having to do with addition. Notice 5 plus 0 is equal to 5, and 0 plus 5 is equal to 5. This is the addition property of 0. The addition property of 0. Now, sometimes, particularly in algebra, this is called, or 0 is called the identity element for addition. And it's called that because we're maintaining the identity of this addend when we use 0 as the other addend, you see. The sum here is 5. So we've maintained the identity of this addend when we perform this operation using 0 as the other addend. So the identity element. But we'll call it the addition property of 0. Here's another property. We can add numbers in either order. That is, 6 plus 2 has the same value as 2 plus 6. This is called the commutative property. And the commutative property is all about changing the order under this operation of addition. We can add numbers in any order that we like. Now, I'm associating this word with that property, and that's kind of important. Now, let's compare this or contrast it with this other property, the associative property. Now, notice here we have 2 plus 3 plus 4. We have 2 plus 3 plus 4. The parenthesis is telling us what to do first in this problem. Here, this is saying, let's add 2 and 3 to get 5, and then add 5 and 4 to get 9. Now, does this have the same value as, let's see, what if I add 3 and 4 to give 7? And then add 2 plus 7. Oh, we get the same value, 9, in either case. Now, notice that these two cases involve an association or a grouping of the numbers being added. That here we're adding the first two numbers first, and here we're adding the last two numbers first. Same numbers are being added in both cases, and we are writing the numbers in the same order. You see, so we're not changing the order. We're not using this commutative idea. We are reassociating them or regrouping them. So the associative property has to do with the word grouping. So here's the operative word when we're talking about associative property, and order is the operative word when talking about the commutative property. Certain words and word phrases lead us to the idea of addition. And these, again, you've probably seen these before, but when the word sum is used, or the sum of a couple of numbers, we're talking about adding. The sum of 5 and 2. The tip-off is the word sum because this is the result when we add a couple of numbers. 6 added to 4. Pretty obvious that we're going to add here. 9 increased by 3. So again, we add. The total of 7 and 1. And the word plus also would indicate that we're adding. Now, we talked about adding using a number line a little earlier, but we said that when the numbers get kind of big, we can't use that, or it's a little inconvenient. We could imagine it maybe, but we wouldn't physically write a number line in order to accomplish the addition. We have to use more of an arithmetic process like this. If we want to add or find the sum of 52 and 34, then we want to write the numbers so that it's pretty easy to find the value for that total. And to do that, we arrange the numbers in a particular way. We write 52 and we write the 34 below it so that the digits of the same value line up. Notice that we have ones digits here and we have tens digits here. So we're just lining up digits of the same value in order to accomplish the process or find that total. Now, 2 and 4 is 6, and notice that this is 2 ones and this is 4 ones from the other number. We get a total of 6 ones, you see, in our answer. And 5 tens and 3 tens will give 8 tens. So our answer contains 8 tens and 6 ones. Oh, that's the number 86. You see, that's the idea. Let's go to some larger numbers. What is the total of 745 and 198? Well, once again, we just arrange the numbers so that we can collect the digits that are of the same value. So we would write 745 and then 198. Now, at this point, I want to encourage you to pay some attention to penmanship skills. There is a tendency when numbers get large to do something like, well, with this number, it might be, something like that. Just kind of scribble the numbers because if you take care with this situation, some students tend to think that if you're careful with it, then it indicates that you don't know very much, or that you're smarter if you can scribble or something like that. And quite the contrary is the case. This is a great time to start to develop the organizational skills, the penmanship skills particularly, that will lead to great success in mathematics. And I just have to pause here and say a couple of words about that, because it turns out that throughout mathematics, more is accomplished through organization than is accomplished through some greater mathematical understanding. That if you can organize the work, then you can make great strides in mathematics. You can solve some extremely complicated problems without knowing some great mystical understanding of mathematics. And I know this with great evidence from being in the classroom and seeing many, many students go through this scribbling process and so forth, and thinking that they're illustrating how bright they are by being able to do that and get right answers on easy problems. That's great. But when it comes to more difficult problems, the need for organizational skills becomes greater, but the time to learn it is right here. All right, now, the organizational skills idea begins with penmanship. And with penmanship, what I'm talking about is making numbers larger. And let me start this process over. Let me just start to write these a little differently. Here's what you're trying to do. You're trying to create a little more separation between the digits in a number and a little more separation between the numbers themselves. So it's a left, right, and up, down situation. So 745, and I'm going to overemphasize this, 745. You see, I'm creating a lot of space between the digits, and I'm overemphasizing it, but I'm doing it to make a point here. And then the 198, 198, you see. And make your digits so that they are highly legible. You see, make block numbers, block digits here for all of these characters. And now we're adding them, and now it's pretty easy to tell about our columns here for digit value and all of that kind of thing. But I encourage you strongly to do this. Okay, now let's go through the process. 5 and 8 is 13. So we have 13 ones. But we only have room here in this ones column for a single digit. And you know from experience that in this 1 and 3, we have 13 ones. Well, this means 3 ones and 1 10. You see, we have accomplished enough ones in order to give us a 10 over here. So the 1 in the 13 moves to this position, and we put the 3 in a position over here in the ones column. So that's the idea. Now we're adding 1 and 4 is 5, 5 and 9, 14. For the 14, rather than putting 14 here, we put the 4 here, and the 1 goes in the next column, you see. So we carry it over to the next column. 1 and 7, 8, and 1, 9. So 943 is our answer. Here's another problem. Suppose we want to add these three rather large numbers. We might begin by estimating what our answer may turn out to be. And we can perform this estimate by rounding our three numbers. 4,252 rounded to the nearest thousand would be 4,000. 6,882 to the nearest thousand is 7,000. And 5,235 to the nearest thousand is 5,000. Now adding these is relatively easy. We can add the zeros. It's a trivial idea from right to left, so we just get zeros brought down. And then we add 4 and 7, that's 11, and 5, 16. So 16,000 would be our estimate for the answer. Now our thinking in adding is to start with the rightmost column. So we're adding in this column. We add 2 and 2, 4, and 5, 9. So we get 9 for the sum of the digits in this column. Then our thinking goes to the next column. And we're adding 5 and 8, 13. 13 and 3, 16. So 16 is the sum of the digits in this column. But we can't really write a 16 here because in this column we have room for only one digit. So what we do is we leave the 6 in this column and we carry the 1 to the next column. That is functionally how we do this. There is a rather long-winded mathematical explanation for it, but this is the mechanical way that we handle the problem. So we write the rightmost digit and we carry the left digit to the next column. And now our thinking turns to the next column and we're adding 1 and 2, which is 3, then 3 and 8, 11, 11 and 2, 13. So we have 13, we'll write down the 3 here and carry the 1 to the next column. Now I'd like to show you something about adding the digits in this column. Sometimes it's a little bit faster to think about whatever digits you may see in a list like this that add to 10. Here, for example, the 2 and the 8 would together give us 10. And then, after thinking about the sum of those digits giving 10, think about adding the remaining digits involved in the problem, you see, to give the total, and in this case the total is 13. Sometimes it's just a little bit easier mentally to handle the problem in this way, to look for digits that total 10. In this column, for example, the digits that total 10 would be 6 and 4. We would think, oh, 6 and 4 is 10, and then 1 is 11, and 5, 16. Or we could just start at the top and say 1 and 4, 5, 5 and 6, 11, 11 and 5, 16. Any way you cook it, we get 16,369. Now do notice that this answer is very close to the estimate that we made at the beginning of the problem. So it's probably correct. If we got something that was substantially different from 16,000, then we would know to look for an error. But this answer is very close to the 16,000 estimate that we made earlier. From time to time, we'll use the calculator to perform operations. And here we're going to use the calculator to add a couple of numbers. Calculators are handy because they can perform operations incredibly quickly and incredibly accurately. But we don't want to become too dependent upon the calculator. We don't, for example, want to add a couple of one-digit numbers using the calculator. If you find yourself doing that, then the calculator is not a tool that you are using. It's as though the calculator is using you. You see, you are dependent upon that calculator, and you don't want to do that. You want to think of the calculator as a tool to use in certain circumstances, but not in all circumstances. All right, so keep that in mind. Now, if we're adding a couple of numbers like 285 plus 520, the use of the calculator is rather straightforward and pretty much obvious. You enter 285, you press the plus sign on the calculator, you enter the other add-in 520, and you press the equal sign or the enter button, and you'll get the result. Now, it is possible, though, to make a mistake in entering the digits here or in pressing the operation symbol. And so it might be a good idea to estimate what you expect the answer to be and make sure that the answer is in the neighborhood of the estimate. Now the estimate here is pretty easy to perform. You see, 285 and 520 are both numbers that are in the hundreds, so we might round these numbers to the nearest hundred in order to create our estimate. You see, 285 to the nearest hundred is 300. 520 to the nearest hundred is 500. 300 and 500 is 800, and we could probably accomplish the estimate in our head. Now, suppose that in performing this operation, in pressing the calculator keystrokes and so forth to accomplish this, we get a number like 148,200. You see, if we had gone to the trouble of going through this and finding the estimate of 800, we would compare these two and say, no, this can't possibly be the right answer. We must have done something wrong. You see, and then we would go through it a little more carefully the next time, and we would find the right answer. And the right answer turns out to be 805, I think, which is in the neighborhood of the 800, as we would expect. And you might be thinking, well, how could we possibly get a number like this? Well, you can get a number like this if you just make the mistake of entering the incorrect operation symbol. You see, if you multiply these instead of add them, then you could get something that is way off base, but you would see that mistake if you just go to the trouble of making the estimate. Here's a word problem in which we need to add some whole numbers to find the result. It says, a paycheck shows deductions of $225 for savings, $98 for taxes, and $27 for insurance. Find the total of the three deductions. When it says find the total, you see, it's the tip-off that we're going to need to add. So we're going to need to add the 225, the 98, and the 27. Now, in word problems, it's important not to become confused if there is extra information or something like that. We see the word 3 here. We associate that with the number 3. We might think, well, maybe 3 needs to be added in here as well. No, because it says we're going to add the total of the 3 deductions, you see. So don't just blindly go off and look for numbers to add. We need to add the things that are requested in the problem, and that's kind of an important thing to keep in mind. Anyway, we're adding the 225, 98, and 27, so we begin by writing those in a particular way, 225, then 98, and then 27. Notice how I'm aligning the ones digits, the tens digits, and this hundreds digit, and now away we go. 5 and 8, 13, 13 and 7, 20. I'll put down the 0 in 20 and carry the 2. 2 and 2, 4, 4 and 9, 13, 13 and 2, 15. I'll put down the 5 and carry the 1. 1 and 2, 3. So 350. Once you have arrived at the total, this is not the final answer. It's important to write the final answer in some kind of complete sentence, or at the very least put a unit associated with the number that we have. This is $350, and this is the total of the 3 deductions. So we might say the total of the 3 deductions is $350 as our final answer.